So really challenging to keep moving forward here when some of us are so far behind backwards. So we'll try to figure out something on that latest test. That's fresh. That was understandable. We had our bad kind of things happening. That's why we ended up going remote. So we'll figure that out. I just don't know what it is right now. So yesterday, and you guys on Monday, you better darn well have done something. All right, you better have looked at that note video and taken that to heart and actually did the ed puzzle. And this is where I get a little despondent because I did say we had to do an ed puzzle, and I got about 30 to 40% of the people still not doing that stuff. So and the grades on the test show this stuff. It just let's just get going, man, and finish strong, I guess is all I could say to make this move forward. So this assignment shouldn't have really been too bad. I really don't like how the book approaches some of the graphing. So some of those graphing questions are kind of crappy in there. And I agree with that. But that's why today I put this assignment here, and it really does coincide with yesterday's notes. So actually, I'm going to start by opening that book. And there it is. Hopefully it scrolls. There we go. And the questions are actually not that bad. Come on. So I've got too many things going on at once. Ooh, this could be one of those classic technology burnouts. That would be great. Oh, that would just be perfect in my mood that I'm in right now. So look at number one. And it says tell whether it's growth or decay. This is section 3.2. This is what I just put on the calendar today. It's going to be so easy because number one is growth, because that number 1.01 or 0.09, I'm sorry, is greater than one. So that increases things. But also recognizing that that's 0.09 or a 9% growth rate per year per time. Okay. And then number three, well, that number is less than one. So that will knock this number down. So I did pull this out. Oh boy, I'm not ready. I got to delete the notes here real quick. Don't look. Don't look. Good thing this is on my notes video for the day. Delete. Delete. And go down to the bottom. These are our notes for Wednesday. Don't freak out. Oh my gosh, look at all those notes. He's the worst. Okay. I can't lasso it, so I can't go yeehaw here because it'll delete the questions themselves. But I pulled questions from the book just to make sure your mind's in the right spot. So there's that number three I was talking about. That number is less than one. So this is a decaying, decreasing, going smaller scenario. So what is the rate that it's decreasing by? You want to go ahead and subtract these two. And I did. I think I got, let me see my calculator. I got rid of it. Okay, but I think when I subtracted those, I end up getting 0.032, which means a 3.2% rate of decay. You could call it a negative, or if you call it decay, then we know it's a negative R value. So that's what we're looking at those. I'm going to go back to the book. Look at number seven's answer. Just to piggyback off the notes that we had. It's not scrolling, not scrolling, not moving. I love the internet. This is going to be great. All right. Anyway, initial value equals 5. Oh, great. It's perfect. Okay. What's going on now? Locked. Okay, great. We're just moving around here. So I guess I can't go ahead and do that. So I was going to show you some other answers. Here's number 18. The reason I like this is having, that's half-life. Okay, so when we look at this, y equals a times b raised to the x. Half-life questions, b is a half. It says the initial mass is 17. Fine, that's 17. And then, but the half-life for the halving is once every 32 hours. There's nothing I can do but just tell you. The exponent's x divided by 32. So one thing you got to remember for half-life questions. The reason is what I showed you yesterday. If I plug in 32 for x, 32 divided by 32 is 1. Half to the first is half. Half times 17 is 8.5, which is what should have happened in 32 hours if the half-life is truly 32 hours. So when I plug in 32 for x, that makes that happen and satisfies the scenario. And then in the homework, oh, do I dare go back up to this? Let's give it a try just for giggles. Scroll, scroll, scroll. Ooh, what's this? Just a black screen. Okay. So yeah, you can see those questions, right? Great. Um, I wasn't gonna initially do number 29, or I was, and then I took it out of the homework. But then I'm like, why did I take it out? So let me just at least reference it. And then I left 33, which is just another half-life question. I mean, it really isn't a big deal. So what is this formula? Well, again, it's y equals a times b raised to the x. And 2000, the population of Jacksonville was this. Well, let's make that the initial population. Let's call that year 0. And then 2010 will be year 10. The year 2100 will be year 100, so on and so on and so forth. 736000. Now, increasing at a rate of 1.49%, which is equal to, I can't help you if you don't know your grade school percentages. 1.49%, you move the decimal twice over, that is equal to 0.0149 as a usable decimal is the best way to say that. And then what is this b? B is always equal to 1 plus or minus r, depending if r is an increase or a decrease. In this case, it's an increase. So it's 1.0149 for Jacksonville. X, T, doesn't matter. I think I used X sometimes, T on other times. Usually the exponent is the time component. In this case, in years. All right. And then that's the equation. So that answers up to this point. All right. Just from that information, that is the growth equation for Jacksonville. When will it be a million? Well, that's when a million is the new value. And I wish we could wait on these and use logarithms in order to solve this, but we're going to pretend we don't know what logarithms are. Many of you probably don't, even though you did a lot of logarithms last year. So since we don't know what a logarithm is, we have to go to the graphing calculator and type this in y1 and y2 and find the intersection. For the love of dog, at least have the idea that if I'm going to see these graphs, y equals a million is like a redonkulously large y value. So I probably want to make the y maximum like 1,200,000. I always want to make it a little bit bigger than the line that I'm dealing with, because then here's where y equals 1 million would be. Like there's 1 million and you'd see a horizontal line. So at least be able to see it in your picture. All right. And then how many years will this take? I don't know. May take 20 years, may take 30, may take 10. Let me make it try like 30 years and see if that's good enough. And if I still don't see them intersect, then I have to extend the years out. But I think that's going to be good enough. And then you'll see an exponential do that. And that is the Y2 graph right there. All right. And then it's the intersection, and you want the X value of where those two intersect. Okay, so without having logarithms yet, that's what we need to do. Okay, all right, so now here's why I'm doing what I'm doing. Hopefully my calendar at least shows up. Oop. Hey, all right, it works. It's a miracle. Okay, so kind of talked about a couple of those assignment questions. Well, then I was worried about this ed puzzle, which I do expect you to do this tomorrow. Part of why I'm such a crab right now, I'm sick of seeing how many people are not doing the ed puzzles. I'm fed up with it. It's getting to the point where I don't know what's going on with you. And all I can say is plead that we all do the right thing the rest of this semester and finish off December strong. Okay. So this is what I expect you to do tomorrow, which is properties of logarithms. And you'll hopefully remember that from last year. According to Mrs. Westberg, you've all done this before. And she said this would be a perfect ed puzzle to do. But what I want to do is make sure you know at least a little bit about um, logarithms before we do that. So the basics. So go ahead and take this down right now. This is our Friday notes, but I want to make sure you are at least having the definition of a logarithm. So then you can remember that and then also do that ed puzzle more successfully. So this is all a logarithm is. It's just rewriting an exponent. And actually, you have to have this memorized. There is no I don't get it's on this. We're going to really have to do a good job about getting this memorized and getting it figured out. And I will tell you, if you don't, you really will not pass this chapter, meaning you better get the basics of what a logarithm is down. Like, just what is it? Let me see. Boom. There we go. Control E. Sorry. I'm going to get rid of this. Okay. Let's see that. All right. Sorry. Just had to do some schematics there. Okay. So notice what we have here. I have just a basic exponent over here. So here's an exponent. And I went ahead and did something with this. I already see really what a logarithm is it's the inverse of a logarithm. When I say inverse, you should say switch X and Y or domain and range exchange. So what I did is I made it not b to the x equals y. I switched x and y already, but you don't have to worry about that. Don't worry about that. This is what you have to know. B raised to an exponent y equals some answer. When I change this to a logarithm, all it does is reposition those spots. So log base b, that's where the base goes, of the answer equals the exponent. And then here's the whole reason why the algorithm log exists. It's so you can isolate the exponent and get it all by itself and then be able to solve for the exponent. So it is a mysterious algorithm. Logarithm. Log is a mysterious logarithm that rearranges the positions of an exponent or an exponential equation. So the exponent is actually essentially isolated. And then in both classes, and then including yours and the video, I'm going to put like what we should have is like basic questions on this. Like, here's an exponent. How do I write it as a logarithm? Well, let's put some true statements here first. Let's change the color so it sticks out a little bit. Like 6 squared equals 36. Ain't no rocket science. That is a true statement. That written as a logarithm, though, would look like this. Log. So as soon as you put that word log there, these positions change. Log base 6, the base is the little subscript of answer 36 equals the exponent all by its lonesome. And there is no I don't get it. This is just what it is. And you just need to know that that's what those positions mean when you see a log question. When you see a log question, you must know that is the base, that is the answer, that is the exponent, and that is your job. All right. I just get real adamant about just knowing that position and knowing the definition of those positions, because there's nothing I could do if you don't get those memorized. Ooh, what about this one? 2 to the negative fourth. Hey, go on the chat. What is 2 to the negative fourth, by the way? Because a lot of times in exponents or logarithms, it's not the logarithms that mess you up, it's your exponent rules and knowing like what the evaluation of that is anyway in the first place. So what is 2 to the negative fourth? Come on, someone chat it up. Show your math skills. Time we got here, 2:30. Nobody's going to do it. 10, 9, 8. We're on YouTube. 7, 6. Nice. Oh, close. What's 2 to the 4th power, actually? I do like that you have a fraction, but I think you got to think about what 2. Nice. There we go, Emily, Alima, and then Lindsay. Pretty much all a tie in that one. That was like speed of light. So it is 1 over 16. So that's my point. If this was written as a logarithm, first of all, it'd be log base 2 of 1 over 16, and then you'd have to evaluate this. So you'd have to know 2 to what power equals 1 over 16, and the answer is -4. All right, so I did write it as a logarithm. I just wanted you to know. A lot of times it's the exponent rules. Okay. All right. So here's these questions. Log base 2 of 8 in the chat. What do you think the answer is? Nice. All right, I'm going to go ahead and Adriana blew everyone away on that one. I'm going to write what this actually asks. What, or sorry, wrong. 2 to what power? Yuck. Equals 8. That's what this is saying or asking. And that's why Adriana is correct. The answer is 3. Come on. All right, next. It's more of a melodious voice, actually. The next one. What is the square root of 3 equal to? 3 to what power? Ooh, good. I see some eye crinkles on that one. Do you remember this? Like the cube root of a squared, that equals a to the 2/3 power from chapter PR, plus from your mathematical lives of supposed to knowing that before you come in here. So what is the power? Oh, close. What is the power on 3 that equals the square root of 3? It's not third power. It's half. There you go. And James locked in there too. Square root is the invisible index on a radical. So when we ask log base 3 of 3, it is asking 3 to what power? You know what? To what power equals root 3? And the answer is actually a half. And then that's where logarithms kind of go out the door if you don't know your exponent rules. So that's what's actually true on that one. How about the next one? What's the next answer? Nice. Emily was waiting. Ciao, like a math ninja. Hi, ciao. All right, like chopping a karate board in half. Okay, -2. Absolutely. So knowing your exponent rules, knowing that you get fractions from negative exponents. What's the next one? Nice. Alima was ready. Ocha. All right. 0, because anything to the 0 power equals 1. Okay, so I have another question. What if it was log base 4 of 0? 4 to what power equals 0? Interesting. What does that mean? Okay. All right. What's PID mean? Is that something the kids are saying these days? I don't want to know. Never mind. So what's the answer? Log base 4 of 0. Oh, period. Get it. Period. So anyone know about log base 4 of 0? 4 to what power equals 0? Not going to happen, folks. It's impossible. Go back to the graphing. Remember, there's a vertical asymptote that limits the graph to not quite getting to 0. That means 4 cannot be raised to a number and equals 0. It's impossible. And then what's the last one? Log base 7 of 7. Nice. 1. Okay, so hopefully logarithms will not be that big of a deal. Okay, so we'll end with this, and we're going to continue with this probably on Monday. No, what's today? Where are we? What month is it? Today's Wednesday. All these changes in schedule, I can't keep track of anything. Um, so on Friday, I'll probably also do a little bit of graphing of exponentials as well, and some. But we're going to continue with this. But I'm going to have this up here, and the reason is when I go to the calculator, there's actually two spots where there's a logarithm. All right, there's this one, clear, 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 log. Now, I hit it. There we go. Now watch why this works. See that log button? It doesn't have a base there, but the base by default is 10. So that's called the common logarithm. Sorry, finishing that off. So what should log base 10 of 10 equal? What should I get for that? What's log base 10 of 10? What should I get when I press enter here? Oh, I was waiting for the chat. Nice. And there you go. So that proves that this base on this logarithm is 10 mysteriously. And then ln, that is actually log base e. And e is a special little number. First of all, let me put e in this logarithm here. So this should give me 1, log base e of e. Same thing as log base 10 of 10. So I just thought I'd show those two things and then go back and show these logarithm property rules. So the first one is called the common logarithm. It's log base 10, but you will not see the base. It's the invisible sneaky base. Okay. And then these should make sense. Log base 10 of 10 is 1 because 10 to the first is 10. Log base 10 of 1 is 0 because 10 to the 0 equals 1, which they have over here. So I do like the stuff that they have here. This one, log base 10 of 10 to any power equals that power. So log of 10 to the 21st power, that would equal 21. All right. That's what that third rule says. Fourth one, don't worry about that one too much. We're going to talk about that on Friday. Going back over here, ln is laziness of mathematicians. Log base e is 4 letters. Oh, that's too much. Let's just write that as 2 letters and now call that log base e. So that's what we need to know about ln. It's actually log base e by disguise. And by the way, you probably should write this down, even though in our shortened time together, we won't get to investigate this too much. E is 2.718. I did this with the other hours. Hey, pi is a number that's special, an irrational number, and it deals with circles. E is a special number that deals with growth and decay specific scenarios. So that's why it often is brought up with logarithms. We won't get to investigate it too much, though, because we have to shorten what we're teaching you. It's another part of my despondence. I just got to deal with it. Just got to maybe go to sleep, reboot my mind, and have a better mood on Thursday. That's how the mind works. It's just like a computer, guys. Sometimes you just got to shut it down and restart it. Mr. Samuelus definitely needs one of those. So have a good day, everybody. Sorry if I brought you down with my being in a bad mood.